Hi, this is Nathan Tintle. In this Learning Goal video, we will talk to you about how to carry out a chi-squared test using the sham acupuncture example from the Introduction to Statistical Investigations textbook. To do this, we will use the multiple proportions applet. Let's go there now. I've pasted in the sham acupuncture data. You can see that the proportion of patients who show improvement is lower in the group that received no acupuncture and larger in the group that received both traditional and sham acupuncture. You'll see that the default statistic down here at the bottom is the MAD statistic. We're going to change that to the chi-squared statistic, receiving a statistic of 38.05. If I scroll down and click the Show Chi-squared Output button, I receive a chi-squared table which includes a p-value that's in this case very small, 0.0000. This is very strong evidence that there is an association between the type of treatment you received and the proportion of individuals who showed improvement. To follow up this test, you can scroll over to the right and click the box for Compute 95% Confidence Intervals. This will compare each of the groups to each other group. You'll see that while there is no evidence of a difference between the real acupuncture and the sham acupuncture groups, both groups are different than the no acupuncture group. The real group minus the none group gives a 95% confidence interval between about 13.5% to 26.9%, meaning that's the improvement of the real acupuncture versus no acupuncture at all. While the confidence interval for sham acupuncture is a little bit smaller, 10% to 23.5%, it still does not include zero, showing significant evidence of a difference between those two groups. Asterisks are used in the applet to indicate which intervals do not include zero, meaning evidence of a difference in those two groups. A couple of words of caution. A chi-squared test is appropriate whenever you have two categorical variables, as long as validity conditions are met. If you do use a chi-squared test when both of your variables are binary, that is, they both have two categories, the p-value you receive from the chi-squared test will be exactly the same as you receive from a theory-based test, a z-test, as long as that z-test is two-sided. Finally, when you receive a significant overall test, that is, the chi-squared statistic is large enough so that you can reject the null hypothesis, you should follow up with individual group comparisons, and more sophisticated approaches do exist for that follow-up than the one that we show you here, but this basic approach of taking each group and comparing it to each other group using something like a 95% confidence interval is a first look at which groups are significantly different than which others.